Hello students, welcome to your channel Parivartan Physics. See, in today's video we'll learn everything about a practical called as spring constant. Using a helical spring, we are going to find the spring constant of the given spring, right? Okay, we'll see in detail about the experiment. See, if you are new to this channel, please don't forget to subscribe the channel and share the channel as well as share the video with your friends and with your juniors, please, right? Okay, and dear students, you can find number of useful videos in this channel. Please go through the channel and go through the playlist. You will find number of useful videos which will surely help you, which will surely boost your preparation for NEET KCET board exams as well as practical examinations. So please go through the channel once and don't forget to subscribe the channel. Okay. Now let us begin the experiment in detail. First we'll see about the apparatus. Okay. Okay. So this is the apparatus which we are going to use, which is called as helical spring, right? So this is the helical spring. See, helical spring this is actually the helical spring, right? This is actually helical spring. This helical spring is one end, upper end, it is attached to a rigid support, and the lower end is attached with a hook. As well as it has a pointer. Here we have a pointer, this is the pointer, right? And here we have a scale, right? This is the scale, and this is the pointer. Okay, here we have the weight hanger. This is the weight hanger. The weight of this hanger is 50 grams. This 50 grams of the hanger, right? So this is the weight hanger, and we are using slotted weights here. These are the slotted weights. Each weight is of 50 grams. This 50 grams of the weight of it, correct? Okay, and other than that, we are going to use a stopwatch. So this is the stopwatch which we are going to use here. See, this stopwatch use there are totally 3 buttons here. 1, 2, and this is 3, right? So first you should observe whether all the digits are 0 or no. Ivella digits ಇಲ್ಲಿ ಏನು ಕಾಣಿಸುತ್ತೆ ಇವೆಲ್ಲ 0 ಇರಬೇಕು. If it is not 0, go on pressing the middle button until you get everything 0, right? So if it is at 0, then never use this middle button. Mode button use ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗಬೇಡ್ರಿ. Okay, see, ಇಲ್ಲಿ start stop button ಅಂತ ಏನಿದೆ, right side button, you just press it, then the time will start running. ಅವಾಗ time ನಮಗೆ run ಆಗ್ಲಿಕ್ಕೆ ಶುರು ಆಗ್ತದ್ರಿ. If you want to freeze the time, if you want to stop the time, then press the same button again. But same button, ಅದನ್ನ button ಮತ್ತೊಮ್ಮೆ press ಮಾಡ್ರಿ, it will become freezed. ಅಂತಂದ್ರೆ ನಿಮಗೆ time ಅಲ್ಲಿಗೆ ನಿಂತು ಬಿಡ್ತದ್ರಿ. If you want to reset it for 0, ಈ right side button use, left side button use ಮಾಡ್ರಿ, it will again get reset for the 0. Correct? So this is how we have to use the stopwatch, right? Okay, that's all about the apparatus which we are going to use. Now we'll go for the formula, principal formula, and then we'll go for the observations, and then we'll go for the procedure clearly, right? Okay. Okay, so this is the chart we are going to follow. As I have told you in all the practicals, there is no need of writing aim, apparatus and procedure in your practical examination. Aim will already be given, right? Okay, so all that you have to write is, you should start from principle. You have to write the formula, diagram, nature of graph, the nature of graph, and observations, observation table, calculation, and result with the unit you have to write. Okay, see, the practical aim is spring constant. Aim of the practical is to find the force constant and effective mass of the helical spring by plotting t square versus m graph using the method of oscillation. We have to find force constant and effective mass of the helical spring. Okay, now what is this force constant? We know very well in a spring, for example, if this is the spring, see, if this is the spring, and if it is at mean position, ಇದಕ್ಕೆ ನಾವು ಅದರದ್ದು mean position ಅಂತ ಕರಿತೀವಿ. mean position ಅಂದ್ರೆ ಏನು? when it is at rest, mean position ಅಥವಾ equilibrium position ಅಂತ ನಾವು ಕರಿಬಹುದು ಅದನ್ನ, right? If I extend this up till this point, ಇದಕ್ಕೆ ನಾವು extreme position ಅಂತ ಕರಿತೀವಿ. This is called extreme position 1. This is extreme position 1. So when I pull it downwards and if I release it, it starts oscillating vertically. So from extreme position 1, it will come here, right? It will go in this direction. This is said to be extreme position 2, right? So when you release it from extreme position 1, it will go to extreme position 2 and it will come back to extreme position 1. So this is said to be one complete oscillation. Position 1 to position 2, back to position 1. For here at this position, ಅಂದ್ರೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೋಗಿ ವಾಪಸ್ ಇಲ್ಲಿಗೆ ಬಂತಪ್ಪ ಅಂದ್ರೆ ಒಂದು oscillation complete ಆಯಿತು ಅಂತ ಅರ್ಥ. See, to bring this mass attached to the spring from this position, from mean position to extreme position 1, we have applied an external force to that. Now one external force and apply ಮಾಡಿ ಅದನ್ನ ನಾವು ಇಲ್ಲಿಗೆ ತಗೊಂಡು ಬಂದಿದ್ದೀವಿ. For extreme position 1, we have got it by applying an external force. If I release it, ಅದನ್ನ ರಿಲೀಸ್ ಮಾಡಿನಪ್ಪ ಅಂತಂದ್ರೆ ಅವಾಗ ಏನಾಗ್ತದ್ರಿ, this mass will go back to its mean position and then to the extreme position 2. So to bring it from mean position to extreme position 1, we have applied the force. It is called external force. But to take it back from extreme position 1 to the mean position, we have not applied the force. So idu vapas mean position ku hoglikke, what is the reason? To get it back, to bring it back to the mean position, what is the reason? The reason is restoring force, which will be developed in the spring when it is stretched or compressed. Right? So our mass namaga vapas mean position ku hogbekadre, the restoring force which will be developed in the spring, that is the reason to bring this mass back to its mean position. That is called restoring force. So ಈ restoring force ಯಾವಾಗ ನಮಗೆ ಡೆವಲಪ್ ಆಗ್ತದಪ್ಪ ಅಂದ್ರೆ ಸ್ಪ್ರಿಂಗ್ ಒಳಗೆ, when it will get developed in the spring, when the spring is extended or when the spring is compressed, at that time this restoring force will be developed. So this restoring force will be directly proportional to the displacement. Displacement ಅಂದ್ರೆ ನೋಡ್ರಿ, ಈಗ ನಾವೇನ್ mean position ದಿಂದ ಇಲ್ಲಿ ತನಕ ತಗೊಂಡು ಬಂದ್ವಿ extreme position 1 ತನಕ, ಅದಕ್ಕೆ displacement ಅಂತ ಕರೀತಾರೆ. It is directly proportional to displacement. And when we remove the proportionality symbol, we'll get a constant called as K. Right? So K is equal to now barkontre restoring force divided by displacement. So this is force constant or spring constant anta karitare. This is called force constant or spring constant. Right? So it is restoring force per unit displacement. Restoring force per unit displacement is called force constant or spring constant. Okay, see, this is restoring force the unit namagu meter ಆಗ್ತದೆ, displacement sorry Newton ಆಗ್ತದೆ, displacement the unit namagu meter ಆಗ್ತದೆ. So the unit of restoring force or spring constant is Newton per meter. Clear? Okay. So the what is the principle? Principle is when a loaded helical spring is allowed to execute oscillations, spring constant K will be equal to 4 square by m. Effective mass of the helical spring will be m naught anta ಹೇಳ್ತಾರೆ. Okay. ಇಲ್ಲಿ spring constant the formula ನಾವು 4 pi square divided by m ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ, where m is the slope of the graph which is plotted with mass versus t square. Mass versus t square graph the slope ಅದು 4 pi square by m. Effective mass of the helical spring m naught. Right, intercept on x-axis. ಇಲ್ಲಿ ನಾನು ನಿಮಗೆ nature of graph ಒಳಗೆ ತೋರಿಸ್ತೀನಿ. See, this is t square, this is m. Correct? So ಈಗ ನೀವು m versus t square graph ಹಾಕೊಂಡಾಗ ಈ ತರದ ನಿಮಗೆ ಸ್ಲೋಪ್, ಈ ತರದ ನಿಮಗೆ ಲೈನ್ ಬರ್ತದೆ, ಗ್ರಾಫ್ ಬರ್ತದೆ. If you extend this backward, ಇದನ್ನ backward extend ಮಾಡ್ಕೊಂಡಾಗ ಅದು x ಕ್ಕೆ ಎಲ್ಲಿಗೆ ಬಂದು intercept ಆಗ್ತದೆ, x ಕ್ಕೆ. So this is said to be the effective mass of the helical spring. So intercept of x-axis, negative x-axis the intercept ಏನದ, that will give you effective mass of the helical spring. That is what we are going to note down. Right? So that's all about the principle as well as formula of the spring constant. Now we'll go for the diagram as well as the nature of graph and observations. See, this is the rigid support as you will see it in the apparatus. This is the helical spring. Illi namagu pointer ada. This is the hook, and here we have applied the load. Correct? Okay. Nature of graph nodri. We are going to draw a graph of m versus t square. M mass, and this has to be in kg, versus t square. T square ಅಂತಂದ್ರೆ time. It has to be in second square. Time ನಮಗೆ second square ಒಳಗೆ ಇರಬೇಕು. Slope is equal to AC divided by BC. AC divided by BC. This is the slope. Right? Okay. Now we'll go for the observation table. See, observation table is load m in kg. ನಾವೇನು ಲೋಡ್ ಹಾಕೊಳ್ಳೋದಿಲ್ಲ ಅದು ಲೋಡ್ ಅಥವಾ ಮಾಸ್ ನಾವಿಲ್ಲಿ ಬರಿಬೇಕು in kg. And for 10 oscillations we are going to calculate the time. See, 10 oscillations ಅಂತಂದ್ರೆ ಈಗ ನಮಗೆ ಇದು equilibrium position ಒಳಗದೆ. Right? If I extend it and if I bring the load up till this point, this is extreme position 1. This is extreme position 1. Right? Okay, if you bring it here and if you release it, it will go upwards and it will come back to extreme position 1. So as we have discussed already, extreme position 1 to extreme position 2 back to extreme position 1, that is said to be 1 oscillation. Correct? So ಈ ತರ 10 oscillation ಗೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕಲ್ಲ ಅದನ್ನ ನಾವು ಟೈಮ್ ಇಲ್ಲೇ ಬರ್ಕೋಬೇಕು. Okay, see, in this practical we are going to start the first trial from 100 grams. 100 grams. So 100 grams ಅಂದ್ರೆ ನಾ kg ಒಳಗೆ ಏನು ಬರಬೇಕು, 100 into 10 raised to minus 3 kg. Correct? 100 into 10 raised to minus 3 kg. Right? So this is for the first trial. Second trial. For every trial you go on increasing by 50 grams. 50 grams increase ಮಾಡ್ಕೊಂತ ಹೋಗ್ರಿ. So ಇದು 100 grams, next 150 grams, 150 grams, 200 grams, 200 grams, 250 grams. I am expressing this in kg, 10 to the power minus 3, ಆಮೇಲೆ 300 grams. So like this mass we are going to increase. ಇಲ್ಲಿ ನಾವು ಬರೆದಿರೋದೆಲ್ಲ kg ಒಳಗದರೆ, ಬಟ್ ನಾವಲ್ಲಿ ಹಾಕೋದು ಮಾಸ್ ಮಾತ್ರ ಎಲ್ಲ ಗ್ರಾಮ್ಸ್ ಒಳಗೆ ಇರ್ತಾವೆ. 100 grams, 150, 200, 250, 300. Like this it will be. Correct? So these are the masses we are going to add for the loaded spring, and we are going to take time for 10 oscillations, and we'll take it for 2 times. Trial number 1, trial number 2. 2 times ನಾವು ಅದನ್ನು ತಗೊಂತೀವಿ. Okay? Now we'll go for the apparatus, we'll take the trials, and then we'll come back to the observation table. Okay, now let us go for the procedure. See, here, for the first trial, as we have already seen, for the first trial, we are going to attach a mass of 100 grams. ಈಗ ನಮಗಿಲ್ಲ we are having the hanger here, right? So the hanger ಎಷ್ಟು mass ಅದ ಅಂತ ಹೇಳಿದೀನಿ ನಾನು ನಿಮಗೆ. This hanger is of 50 grams, right? So if I add this, if I attach this hanger here, if I hang this hanger here, I have attached 50 grams of mass to the spring. For the first trial, we are going to add 100 grams. So this stand is of 50 grams plus along with that stand, I am going to add this 50 grams mass for that, right? So I will add this 50 grams mass to that hanger, right? So this is how we have to add the mass. Okay. So now the load or mass which we have added to the spring is of 100 grams, right? So the first trial we are going to take, as I have told you, we have to count the time for 10 oscillations of the spring. See, when we can say one oscillation has been completed, ಈಗ ನಮಗೆ spring ಇಲ್ಲದೆ, here the spring we have. If I pull it downwards and if I release it, the spring will go upwards and it will come back downwards. So like this, it will start oscillating. Vertical oscillation ನಮಗೆ ಇರ್ತದ್ರಿ. It start oscillating vertically, right? So if I extend the spring and if I bring it up till this point, ಆ ಮಾಸ್ನ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ತಗೊಂಡು ಬನ್ನಿ ಅಂತಾರೆ, ಇದಕ್ಕೆ ಎಕ್ಸ್ಟ್ರೀಮ್ ಪೊಸಿಷನ್ ಅಂತ ಕರಿತೀವಿ. So from this extreme position to this extreme position and back to the same extreme position is said to be one oscillation. ಈಗ ನಮಗೆ one oscillation complete ಆಯ್ತು ಅಂತ ಅರ್ಥ, right? So from here, this is the first extreme position, this is the second extreme position. First extreme position to second, second to first. This will give, this is said to be one complete oscillation. So ಇಂಥವು ಎಷ್ಟು oscillations ಆಗಬೇಕು? 10 oscillations should happen. Then how much time is taken for 10 oscillation? That is what we have to note it down, right? So this is the first trial we are going to take. See, 10 oscillations ನಮಗೆ ಎಷ್ಟು time ತಗೋತದ? That is what we want to calculate here. So first ನಮಗೆ ಟೈಮರ್ ನಮಗೆ ಈಗ 0 ತೋರಿಸೋದ್ರಿ, it is showing 0. So you start at any one. ಈಗ ನೋಡ್ರಿ, ನೀವು ಟೈಮ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ ನೀವು ಯಾವಾಗೂ ಸ್ಟಾರ್ಟ್ ಮಾಡಬಹುದು. When you release it from hand, at that time also you can start it. Or ಈಗ ನೋಡ್ರಿ, if I release it from the hand, at this instant also you can start it and you can count the 10 oscillations. Or in between, ಯಾವಾಗೂ ಈಗ ಇದು already oscillate ಆಗತ್ತದ್ರಿ. It is already oscillating. So when it comes to the lower extreme position, at that time you start the stopwatch and you count 10 oscillations. ಅವಾಗ ನೀವು 10 oscillations in count ಮಾಡ್ರಿ, right? You can do it anyhow. Okay, see what I will do is, ಈಗ ನಾವು ಸಿಂಪಲ್ ಪೆಂಡುಲಮ್ ಒಳಗೆ ಏನ್ ಮಾಡಿದ್ವಿ, we took it to one extreme position, ಆಮೇಲೆ ಕೈ ಒಳಗೆ ಬಿಡಬೇಕಾದ್ರೆ ನಾವು ಸ್ಟಾಪ್ವಾಚ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ವಿ. When we release it, at the same instant we start the stopwatch, right? ಇಲ್ಲಿ ನೀವು ಹಂಗೂ ಮಾಡಿದ್ರೆ ನಡೀತೈತ್ರಿ, ಅಥವಾ ಆಸಿಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಶುರು ಮಾಡಿದ್ಮೇಲೆ when it comes to one extreme position, ಇಲ್ಲಿಗೆ ಬಂದ ಕೂಡಲೇ ನೀವು ಸ್ಟಾಪ್ವಾಚ್ ಅನ್ನು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ರಿ, ಆಮೇಲೆ ಆಸಿಲೇಷನ್ಸ್ ಅನ್ನು ಕೌಂಟ್ ಮಾಡ್ರಿ. ಎನಿಥಿಂಗ್ ಇಸ್ ಓಕೆ, ರೈಟ್? ಸೊ ಬಹಳ ದೂರ ಇದನ್ನ ಎಳಿಲಿಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ. ಅಂದ್ರೆ ಡೋಂಟ್ ಎಕ್ಸ್ಟೆಂಡ್ ದ ಸ್ಪ್ರಿಂಗ್ ವೆರಿ ಮಚ್. You just extend it lightly and then you release it. It will oscillate uniformly so that its oscillation should not get disturbed. ಅಥವಾ ಆಸಿಲೇಷನ್ ಡಿಸ್ಟರ್ಬ್ ಆಗಬಾರ್ದ್ರಿ. ನೀವು ಬಹಳ ಜಗ್ ಬಿಟ್ರಿ ಅಂದ್ರೆ ಅದು ನೋಡ್ರಿ ಸ್ಲಾಕ್ ಆಗ್ತದೆ. ಲೈಕ್ ದಿಸ್ ದ ಆಸಿಲೇಷನ್, ದಿಸ್ ಇಸ್ ನಾಟ್ ದ ಕರೆಕ್ಟ್ ಆಸಿಲೇಷನ್, ರೈಟ್? ಸೊ ಅದು ಕರೆಕ್ಟ್ ಆಗಿ ಆಸಿಲೇಟ್ ಆಗ್ಬೇಕಾದ್ರೆ ಯು ಡೋಂಟ್ ಎಕ್ಸ್ಟೆಂಡ್ ಇಟ್ ಟೂ ಮಚ್. ಅದನ್ನ ಜಾಸ್ತಿ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ. ಜಸ್ಟ್ ಲೈಟ್ ಆಗಿ ಸ್ವಲ್ಪ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ಬಿಟ್ರಿ, ಅದು ಯೂನಿಫಾರ್ಮ್ಲಿ ನಮಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ಆಸಿಲೇಟ್ ಆಗ್ತದ್ರಿ ವರ್ಟಿಕಲಿ, ರೈಟ್? ಓಕೆ, ಸೊ ಸಿ, when I release it from the hand, I will start the stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So for 10 oscillations, how much time it has taken? 5 seconds time it has taken, right? Okay, so I will note it down. For 10 oscillations, it is 5 seconds. Clear? Okay, ignore it. I will reset the clock back to the 0. ಈಗ ನಾವು ಫಸ್ಟ್ ಟ್ರಯಲ್ ತಗೊಂಡ್ವಿ ಫಾರ್ 100 grams. For 100 grams, we have taken the first trial. So for 10 oscillations, it has taken 5 seconds. So this is trial number 1. ಇದನ್ನ ಮತ್ತೊಮ್ಮೆ ರಿಪೀಟ್ ಮಾಡ್ರಿ. You repeat the same thing once more. For 100 grams only, for 10 oscillations only, you take it once more, right? See, I will repeat the same thing again. Still the mass is 100 grams only, right? 100 grams mass ಅದ. hook ನಮಗೆ 50 grams plus ಮೇಲ್ಗಡೆ ನಾವು 50 grams add ಮಾಡಿದೀವಿ. So 100 grams ನಮಗೆ mass ಅದ. Clear? Okay. So we'll again calculate the time, count the time for 10 oscillations of this 100 grams. See, just when you release it from your hand, you start the stopwatch. I guess stopwatch is clearly visible for you. See, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? So how much is the time taken? It is 5 seconds again. Clear? This is how we have to take the time for the oscillation of the spring. So for both the trials, for 10 oscillations of 100 grams, we have got 5 seconds time, right? So this is the first trial, trial number 1. What we have to do for the next trial now? For the next trial, we have to add 50 grams more. Matte 50 grams adake add madri. Add 50 grams more to this. Now this is 150 grams. This is how we have to add the mass. So now it is 150 grams. Okay. Okay. After adding 50 grams, again you should repeat the same procedure. Matte same procedure ನೀವು repeat ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ for 10 oscillations only you have to take the time again. Okay, reset the clock. See, I will start exactly when I release it from the hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So this is the time taken for 10 oscillations for 150 grams. 7 seconds time it has taken. Repeat the same thing again. Repeat the same thing again. So for 150 grams, we have taken one trial. We'll take for 150 grams, we'll repeat the same thing again. We'll take one more trial for 150 grams again. See, the mass is already 150 grams. Iga, ida oscillation ನಿಮಗೆ ಗೊತ್ತದ್ರಿ. If it starts from here, ಈಗ ನಾ ಇಲ್ಲಿ ತನಕ ಅದನ್ನ extend ಮಾಡ್ಕೊಂಡು if I release it, if it go up and comes down, it is said to be one oscillation. Right? So 1, 2, 3, 4, like this we have to take it. Clear? Okay. So I will extend it downwards and then I will release it. Hope stopwatch is clearly visible for you. Right? See, we'll count the oscillations now. We'll start the time. See, when you release it, you start the stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? So for 10 oscillations, how much time it has taken? It is clearly visible for you. Right? 7 seconds time it has taken. Okay, note it down. To reset it, press this button. It will become 0 again. Okay? So like this, we have to take the trials for 100 grams, 150 grams, 200, 250 and 300 grams, right? So I will take all the trials and I will note down the values. I will directly come for the observation table now. Clear? Okay. Okay. So I have taken all the trials now. All trials now already two trials I have shown for 100 gram and 150 gram. So rest of them I have taken and we have taken two trials for each mass, right? So mean time nile calculate madidini. First trial 5. So 5 plus 5 is 10. 10 by 2 is 5. Right? Mean antadre add both of this, divide it by 2, you will get the mean. Next period, time period. Time period antandre ena, what is time period? Time taken to complete one oscillation. So is spring extreme position 1 then the extreme position 2 hoge. If it comes back to extreme position 1, one oscillation mugitu antartha. Right? So for one oscillation, how much time it will take? That is time period. Correct? So to calculate time period, what is the formula? T by 10. Mean time divided by 10. So 5 by 10, 0.5, 7 by 10, 0.7, 8 by 10, 0.8, 9 by 10, 0.9, 10 by 10, 1. Right? Here we are going to write T square, time period square. So this is time period square. Then square madi ikade bardevi. Right? So 0.5 square is 2.25, 0.49, 0.64, 0.81, 1. Correct? So these are the observations. These are the readings which we have taken. Next, we have to plot the graph. So we'll go for the graph now. So graph now model plot madkondo. See, T square versus M graph we have to plot. So we'll plot the graph, we'll find the slope and then we'll come back to the calculation. Okay. Okay. Now let us see how to plot the graph, how to draw the graph. See, I have taken y-axis here and x-axis here. See, y-axis na solpa ee kade tagondidane because namaga negative x-intercept beku. That's why I have not taken y-axis here, I have taken it here. Clear? Solpa ee kade tagondri, idu one experiment. Okay, so on x-axis what we are going to take? X-axis we are going to take mass. So here I will show it. We are going to take mass on x-axis and mass will be in kg. Right? On y-axis what we are going to take? We are going to take time square. Time square will be in second square. So first in any practical, ಯಾವುದೇ practical experiment the graph ನೀವು ತೆಗಿಬೇಕಾದ್ರೆ ಆ axis ಮೇಲೆ ಯಾವ physical quantity ತಗೊಂಡಿದ್ರೆ ಆ physical quantity ಮೊದಲಲ್ಲಿ ಬರೀರಿ. Correct? And now you just check what are the trials you have taken. First mass ನೋಡ್ರಿ, mass ನೀವು ತಗೋಬೇಕಾಗಿದ್ರಿ. So mass ನಮಗೆ ಯಾವ ತರ ಇದೆ ನೋಡ್ರಿ, 100 grams, 150 grams, 200 grams, 250 grams, 300 grams. Uniformly ನಾವು increase ಮಾಡ್ಕೊಂತ ಹೋಗಿದೀವಿ 50 grams ಅಂತ. Total 5 trials ಅದಾವ. Right? So how to plot the graph now? ಅದನ್ನ ಯಾವ ತರ ತಗೋಬೇಕು? See, ಇಲ್ಲೇ ನಿಮಗೆ ಬೇಕಾದ್ರೆ you can take the graph for one unit ಅಂದ್ರೆ 1 centimeter. ಇಲ್ಲೇ ನೋಡ್ರಿ ಗ್ರಾಫ್ ಒಳಗೆ ಒಂದು ಸ್ಕ್ವೇರ್ ಬಾಕ್ಸ್ ಅಂತಂದ್ರೆ ಇದು 1 centimeter ಇರ್ತದ್ರಿ. It will be 1 centimeter. If you want, you can plot for 1 centimeter one value. 1 centimeter ಒಂದು ವ್ಯಾಲ್ಯೂ ನೀವು ಪ್ಲಾಟ್ ಹಾಕಬಹುದು. ಇಲ್ಲ 2 centimeter 2 ಬಾಕ್ಸ್ ಒಂದೊಂದು ವ್ಯಾಲ್ಯೂ ಕೂಡ ನೀವು ಹಾಕಬಹುದು. It depends upon the trials. ನಮಗೆ 5 trials ಮಾತ್ರ ಅದಾವೆ. So this is for the first trial, second trial, third trial, fourth trial and fifth trial. Like this I will take it. Correct? For every 2 centimeter I am taking. So for the first trial, how much is the mass? 100 grams. ಅದನ್ನ ನಾವು kg ಒಳಗೆ ಬರ್ಕೋತೀವಿ. 100 into 10 to the power minus 3. For second trial it is 150 into 10 to the power minus 3. For third trial it is 200 into 10 to the power minus 3. And 250 into 10 to the power minus 3. 300 into 10 to the power minus 3, right? So I have taken them in kgs. For every 2 centimeter, I have taken one value, correct? So how to write the scale of this now? See, I am going to write the scale of x-axis. So scale of x-axis. So for x-axis, what is the scale? X-axis, what is the scale? Scale togobekadre nodri illi en madri for every 2 centimeter. Okay, let me make it a little bit clear for you. Salpa navile nodri. For every 2 centimeter, nodri one box antandre one box means it will be 1 centimeter, correct? So ನಾವು ಏನು ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ, ಎರಡು ಬಾಕ್ಸಿಗೆ ಒಂದು ವ್ಯಾಲ್ಯೂ ಹಾಕೊಂಡಿದ್ದೀವಿ ಅಂದ್ರೆ ಫಾರ್ 2 ಸೆಂಟಿಮೀಟರ್. ಸೊ ಫಸ್ಟ್ ಟ್ರೈಲ್ ನೀವು ಫಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಒರಿಜಿನ್ ಬಿಟ್ಟು ಎಷ್ಟು ಸೆಂಟಿಮೀಟರ್ ಒಳಗೆ ಹಾಕೊಂತೀರಿ ಅಷ್ಟೇ ಡಿಸ್ಟೆನ್ಸ್ ಒಳಗೆ ಉಳಿಕಿದ ಟ್ರೈಲ್ಸ್ ಕೂಡ ಇರಬೇಕು. ಇದು ನೀವು 2 ಸೆಂಟಿಮೀಟರ್ ತಗೊಂಡಿದ್ರೆ ಇದು ಕೂಡ 2 ಸೆಂಟಿಮೀಟರ್ ಇರಬೇಕು, ಇದು ಕೂಡ 2 ಸೆಂಟಿಮೀಟರ್ ಇರಬೇಕು, ಇದು ಕೂಡ 2 ಸೆಂಟಿಮೀಟರ್, ಇದು ಕೂಡ 2 ಸೆಂಟಿಮೀಟರ್. ಯು ಕ್ಯಾನಾಟ್ ಡೂ ಇಟ್ ಲೈಕ್ ದಿಸ್. ಇದು 2 ಸೆಂಟಿಮೀಟರ್ ತಗೊಂಡು ಆಮೇಲೆ 1 ಸೆಂಟಿಮೀಟರ್ ಹಾಕೊಂತ ಹೋಗಬೇಕು, ನಾಟ್ ಲೈಕ್ ದಟ್, ರೈಟ್? ಸೊ ಫಾರ್ ಫಸ್ಟ್ ಟ್ರೈಲ್ ನೀವು ಒರಿಜಿನ್ ಬಿಟ್ಟು ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಒಳಗೆ ತಗೋತೀರಿ ಅಷ್ಟೇ ಡಿಸ್ಟೆನ್ಸ್ ಒಳಗೆ ಉಳಿಕಿದ ಟ್ರೈಲ್ಸ್ ಕೂಡ ಇರಬೇಕು, ರೈಟ್? ಓಕೆ, ನೀವು ಇಲ್ಲಿ ಏನಾದ್ರು ಹಾಕೊಂಡಿದ್ರೆ 1 ಸೆಂಟಿಮೀಟರ್ ನೀವು ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಹಾಕೊಂತ ಹೋಗ್ಬೇಕಿತ್ತು. ಸೊ ನಮ್ಗೆ ಎಷ್ಟು ಟ್ರಯಲ್ಸ್ ಇರ್ತಾವ ಆ ಟ್ರಯಲ್ಸ್ ವ್ಯಾಲ್ಯೂ ಕೊಡ್ಬೇಕಾದ್ರೆ ಆದಷ್ಟು ಎಕ್ಸ್ಪ್ಯಾಂಡೆಡ್ ಗ್ರಾಫ್ ಬರ್ಬೇಕಿತ್ತು, ನಮ್ಗೆ ಕ್ಲಿಯರ್ ಗ್ರಾಫ್ ಬರ್ಬೇಕು. ಸೊ ಕೀಪ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಮೋರ್ ಟು ಗೆಟ್ ದ ಕ್ಲಿಯರ್ ಗ್ರಾಫ್, right? So for every 2 centimeter, how much we have increased the mass? 50 grams mass we have increased for every 2 centimeter, right? So that's what I am going to write here. For x-axis 2 centimeter equal to 2 centimeter ಅಂತ ಯಾಕೆ ಬರ್ಕೊಂಡಿದ್ದೀನಿ, ಯಾಕಂದ್ರೆ ಎರಡು ಬಾಕ್ಸಿಗೆ 2 ಸೆಂಟಿಮೀಟರ್ ಒಂದು ವ್ಯಾಲ್ಯೂ ನಾವು ಹಾಕೊಂಡಿದ್ದೀವಿ. 50 grams we have increased, ಅದನ್ನ ಕೆಜಿ ಒಳಗೆ ಬರೀತೀನಿ. 50 into 10 to the power minus 3 kg, right? So write the unit of the physical quantity which you have plotted on x-axis. x-axis ಮೇಲೆ ನೀವು ಯಾವ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಹಾಕಿದಿರಿ ಆ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಯೂನಿಟ್ ನೀವು ಇಲ್ಲೇ ಬರೀಬೇಕು, ಕರೆಕ್ಟ್? ಓಕೆ, ದಿಸ್ ಇಸ್ ಫಾರ್ x-axis, ಕ್ಲಿಯರ್? ಓಕೆ, ನಾವು ವಿಲ್ ಗೋ ಫಾರ್ y-axis. y-axis ಮೇಲೆ ವ್ಯಾಲ್ಯೂಸ್ ನಾವೀಗ ಪ್ಲಾಟ್ ಮಾಡೋಣ. ಓಕೆ, y-axis ವ್ಯಾಲ್ಯೂಸ್ ಯಾವ ತರ ಅದ ನೋಡ್ರಿ. y-axis ಮೇಲೆ ನಾವು t ಸ್ಕ್ವೇರ್ ತಗೋಬೇಕು. ಸೊ t ಸ್ಕ್ವೇರ್ ವ್ಯಾಲ್ಯೂಸ್ ಯಾವ ತರ ಅದಾವ? ಇಟ್ ಇಸ್ 0.25, 0.49, 0.64, 0.81, 1 like this it is, correct? Okay, so let us take the values like this now. So ಇಲ್ಲೂ ಕೂಡ ನಾ 2 ಸೆಂಟಿಮೀಟರ್ ಒಂದು ತಗೋತೀನಿ. See 1 2 3 4 5 6 7 like this will go. For every 2 centimeter I have taken the marking. Okay, so we'll start from 0.25. So this is 0.25, right? And this is 0.50. So ಈಗ ನೋಡ್ರಿ 2 ಸೆಂಟಿಮೀಟರ್ ಒಂದು ವ್ಯಾಲ್ಯೂ ಹಾಕತೀನಿ. 0.25 to 0.50, right? So 0.25 I have increased. ನಾ ಎಷ್ಟು ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದೀನಪ್ಪ ಅಂದ್ರೆ 0.25. ಆಮೇಲೆ 0.5 ಆಗಿದ್ದ ಕೂಡಲೇ ನೆಕ್ಸ್ಟ್ ಏನ್ ಬರ್ಬೇಕ್ರಿ? 0.75. 0.75 ಆಗಿದ್ದ ಕೂಡಲೇ ನೆಕ್ಸ್ಟ್ ಏನ್ ಬರ್ಬೇಕ್ರಿ? 1. I have to get it as 1, correct? So like this the values I have to take. ನೀವು ಇಲ್ಲಿ ಇನ್ನೂ ಇದನ್ನ ಚೇಂಜಸ್ ಮಾಡಿ ತಗೋಬಹುದ್ರಿ. 0.25, 0.30, 0.35, 0.40, 0.45 like this also you can take, right? It depends upon you. ನಿಮ್ಗೆ ಯಾವ ತರ ಬೇಕು ಆ ತರದ ನೀವು ವ್ಯಾಲ್ಯೂಸ್ ಗಳನ್ನ ಪ್ಲಾಟ್ ಮಾಡ್ಕೋಬಹುದು. Okay, now looking at the values in the table, just go on plotting. ಈಗ ನೀವು ಪ್ಲಾಟ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ರಿ. ಇಲ್ಲಿ ನೋಡ್ರಿ, I will show you both of them together. See, for the first trial, how much is the mass? 100 grams. How much is the t square? 0.25. So this is 100 grams, this is 0.25. So this is the first point, correct? Next, 150, 0.49. This is 150, this is 0.50. So 0.49 andre it will be just below that. Here it will be, correct? Okay, next 200, 0.64. See, this is 0.5, this is 0.75. So middle value ನಮಗೆ ಎಷ್ಟು ಇರಬೇಕ್ರಿ? It will almost be 0.625, right? Middle value. So ನಮಗೆ 0.64 ಅದರಿ ಅಂದ್ರೆ above this 200, this is 0.625. So this is 0.64 ಅಂತ ನಾ ತಗೋಬಹುದು. Here I will get it, correct? Okay, next, that is for 200. 250, 0.81. See, this is 0.75. This is 0.1. So 0.85, 85, 8 means somewhere it will be just below this. Beyond andre 0.75 ಗಿಂತ ಮೇಲ್ಗಡೆ ಇರ್ತದ್ರಿ. So this will be somewhere here, 250, and somewhere here it will be, correct? And for 300 it is 1. So 300, here it is 1. Like this we have to plot it, correct? So we have plotted all the values now. Now what we have to do is, we should join any 3 points, any 3 or 4 points ಗಳನ್ನು join ಮಾಡ್ರಿ and come back to x-axis, correct? So like this we can join now. So maximum points ನಮಗೆ ಈ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಮೇಲೆ ಕೂಡ್ಲಿಕ್ಕತ್ತವೆ. So I will join these points and I will draw a straight line, right? So like this we have to take it, right? Okay, so this is the negative x-axis and this indicates the effective mass of the helical spring. Okay, first we'll calculate the slope. Slope calculate ಮಾಡಬೇಕಾದ್ರೆ ನೋಡ್ರಿ ಇಲ್ಲೇ ಒಂದು ನೀವು triangle ತಗೋಬೇಕು. You have to take a triangle. So let me take a triangle here. Let me draw a triangle. So this is going to be the triangle, right? So I will name this as A, this as C, and this one as B. We have to take the values of AC and BC and then we'll get the slope value, correct? So how to take the value of AC and BC? See, AC means you have to take the values on y-axis because AC is parallel to y-axis. BC means we have to take the values from x-axis because BC is parallel to x-axis. So AC notri, AC ನೀವು ತಗೋಬೇಕಾದ್ರೆ A value ನಮಗೆ ಎಷ್ಟದ? How much is the value of A? It is 1, correct? C value ನಮಗೆ ಎಷ್ಟದ? C value ಅಂತಂದ್ರೆ ಇದು for the second trial. So second trial ನೋಡ್ರಿ, ಇಲ್ಲಿ ನೀವು trial values ನೋಡ್ಕೊಂಡ್ಬಿಟ್ರಿ. Trial values, this is trial number 1, this is trial number 2, trial number 3, trial number 4, trial number 5, right? So fifth trial the t square value ಏನದ? Fifth trial the t square value 1 ಅದ, it is 1, right? ಇದೆಷ್ಟನೇ trial? Second trial the t square value ಎಷ್ಟದ? 0.49, right? So here it is 1 and here it is 0.49. So if you minus 1 minus 0.49, you will get it as 0.51, right? So 0.51, this is the value of AC. So I got AC is equal to 0.51 and AC is parallel to t square axis. T square under second square. So I will write it as second square. Clear? Next, similarly, BC. See, B, second trial ನಮಗೆ 150 ಅದ. ಆಮೇಲೆ A is third trial, 300 ಅದ. So 300 minus 150 means, so BC will be equal to 300 minus 150, it will be 150 into 10 to the power minus 3 kg. This much will be the value of BC. Clear? See, we have written the scale of x-axis only. We'll also write the scale of y-axis now. So y-axis notri. Y-axis ಮೇಲೆ ನಾವು ಯಾವ ತರ ತಗೊಂಡಿದ್ದೀವಿ? For every 2 cm I have taken one value, right? How much I have increased? What is the difference? 0.25 this 0.50 ಆಗಿತ್ತು ಅಂದ್ರೆ 0.25 ನಾವು increase ಮಾಡಿದ್ದೀವಿ. 0.5 this 0.75, 0.25 we have increased. So here I have to write, for every 2 cm I have increased the time by 0.25 second square. I am taking second square because here we have taken time square. Clear? Okay. So now we'll calculate the slope. How much will be the slope now? Slope now calculate ಮಾಡ್ಕೋಬೇಕು. Slope is equal to, it is AC divided by BC. AC divided by BC. How much is AC? AC is 0.51. How much is BC? 150 into 10 to the power minus 3. Correct? Okay. So if I take 10 to the power minus 3, it will be 0.51 into 10 to the power plus 3 divided by 150. So 0.51 into 10 to the power plus 3 ಅಂದ್ರೆ ಇದು 510 divided by 150 ಇರ್ತದ್ರಿ. 510 divided by 150. So divide it, 510 divided by 150. It is 3.4, right? So 3.4. This much is the slope, right? We got the slope now. So slope ಅಂದ್ರೆ ನಾವು ಅದನ್ನ m ದಿಂದ represent ಮಾಡ್ಕೋತೀವಿ. m is 3.4 and what will be the unit of this? AC divided by BC. So second square per kg. This will be the unit of slope. Okay, next we have to calculate the effective mass here. Effective mass calculate ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ನೋಡ್ರಿ, you first note down how many divisions the intercept ನಮಗೆ origin ದಿಂದ ಎಷ್ಟು ದೂರ ಇದೆ. So ಇಲ್ಲಿಗೆ 1 cm ಆಯ್ತು. This is 1 cm. 1 ಮುಂದ್ಗಡೆ ನಮಗೆ ಎಷ್ಟು ಸ್ಕ್ವೇರ್ ಬಾಕ್ಸ್, ಸ್ಮಾಲ್ ಸ್ಕ್ವೇರ್ ಬಾಕ್ಸ್ ಎಷ್ಟು ಕವರ್ ಆಗಿದೆ ನೋಡ್ರಿ, 1 2 3 4, right? 4 small box have been covered. So 1.4 length is 1.4 cm. Length is 1.4 cm x intercept. So ಇಲ್ಲಿ ನಿಮಗೆ m naught ಬೇಕಾದ್ರೆ ನೀವು ಏನು ಮಾಡಬೇಕು? Length of the x intercept into the scale of x axis. Scale of x axis ನೀವು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ಲೆಂತ್ ನಮಗೆ 1.4 cm ಇದೆ. ಸ್ಕೇಲ್ ನಮಗೆ x axis ಎಷ್ಟಿದೆ? 50 into 10 to the power minus 3. ಸೊ ಅದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ರಿ. 50 into 10 to the power minus 3 kg, right? So 50 into 1.4. So that will be 70. 70 into 10 to the power minus 3 kg. This much will be the effective mass of the helical spring, and this is the slope, right? This is the slope and this is the effective mass of the helical spring. Okay, now we'll go for the chart and we'll calculate the spring constant now. Okay, see, we'll go for the calculation of spring constant. See how to calculate the spring constant. Spring constant ಯಾವ ತರ calculate ಮಾಡಬೇಕು? The formula is 4 pi square divided by m. Spring constant calculate ಮಾಡಲಿಕ್ಕೆ right? So I will write it here, 4 pi square. How much is the slope? Slope ನಮಗೆ ಎಷ್ಟು ಬಂದಿರುತ್ತೆ? 3.4 second square per kg slope, correct? So 3.4, I will write it as 3.4, correct? Okay, so what I will get, see, you have to substitute the value of pi square as well. So you do 4 into pi square, 3.142 into 3.142, so that is 9.872 into 9.872 divided by 3.4. You multiply these both now, so it is 4 into 9.872 divided by 3.4, correct? So this will be 11.61, right? So what is the unit of spring constant? It will be Newton per meter, right? So this much will be the spring constant. Okay, we got the spring constant and we got the effective length as well. So now let us note down the result. See, result ನಮಗೆ ಇಲ್ಲಿ ಬರಿಬೇಕಾಗ್ತದೆ. So don't forget to write the result. So the spring constant is 11.61 Newton per meter. And how much is the effective mass? It is 70 into 10 to the power minus 3 kg. This is the effective mass, right? Hope you have understood the practical clearly. Dear students, if you like the content of this channel, please don't forget to subscribe the channel. Subscribe ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಮರಿಬೇಡ್ರಿ, ದಯಮಾಡಿ subscribe ಮಾಡ್ಕೊಳ್ರಿ. And please share the video, share the channel with your friends. Please mouth spread about the channel to your friends, right? ದಯಮಾಡಿ ಈ ಚಾನಲ್ ಬಗ್ಗೆ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಹತ್ರ ಮಾತಾಡಿ, ನಿಮ್ಮ ಜೂನಿಯರ್ ಕೂಡ ಇದನ್ನು ರೆಫರ್ ಮಾಡ್ರಿ. Please share and please subscribe, right? Thank you so much. If you need anything else, please put a comment in the comment box. We'll meet again in the next video with the next practical. Thank you.